Okay.
So next talk is by Liz Steininger on private periodic payments protocol. You can go.
Hi, everyone. As you know, I'm going to be talking about something called P4, the 4 Ps of Private Periodic Payments Protocol. I think you all can hear me okay. So a little bit about myself and the company I work for, At Least Authority. So the big thing that you should know is that we believe that people have a right to privacy. Our mission is to make security easy and available to everybody. We help others improve their technologies by doing things like security consulting and security audits. And we also build technology too. We also build technical solutions that incorporate these values, like privacy by design, empowering users to control their own data, and minimizing access that service providers, including ourselves, have to user data. So to talk about how we are a merchant or a service provider, we have something called S4, the Simple Secure Storage Service. This is a distributed cloud storage product, basically, but what that really means is that it's built using open source projects and enables client-side encryption so that the users hold the keys to their data, not us. This also does sharding of the ciphertext, so it gets distributed across multiple places for storage too. And the service doesn't operate on an access control list basis, but instead works using object capability model or key-based access. This is similar to how cryptocurrencies work, which I'm sure most of you know. And this is a little bit different than having users have usernames and passwords to log into the system. So in other words, we don't have any personal account information about the ciphertext that people store with us. And this is important. You either have the capability or the key to access the data, or you don't. And we don't. So this brings me to the problem that we have run into. So we have this wonderful storage product where we don't need to collect information about people in order to provide the actual service itself. But to accept payments, we do need to collect personal data at this point in time. So in order to process fiat currency payments for subscriptions, we need to collect this basic information about them. And this means, collecting personal data just for the payments, which we thought to ourselves, hey, maybe we could change this. Maybe it's possible to do something with privacy where we wouldn't have to collect any personal data at all. So, of course, you guys all know that doing privacy right now is a little bit difficult. But I do believe that the idea of expensive for privacy or difficult, the lack of convenience in some cases, is relative, and I think that this is easily challenged by new technology and people trying to tackle the problem. So what we did was we began researching what the standards are for doing subscription payments with cryptocurrencies. And what we found was quite limiting and didn't meet our needs. One current use for Zcash shielded transactions is to have people prepay for their subscriptions, or just, cryptocurrency in general, people could prepay. And this works for service offerings where you can turn the service off and not have to have any kind of storage or in the interim. And that, like electricity, for example, you can just turn it off, turn it back on again when people pay again. But in our case, because we're storing data, this wasn't exactly the right solution for us because we need to hold that ciphertext. And of course, you can use smart contracts for managing some aspects of subscriptions, but this option with Ethereum and other platforms at the moment is not suitable for either the reason that they're not scalable, they're not usable to the end that we need. Maybe in the future this will be different, or in the case of like Ethereum, there's a privacy concern there too. And then another option is things like pre-authorization, and that also is a problem because we don't want people to pre-authorize payments to us because it takes away their power to change their minds in the future. So if they decide that they want to cancel a subscription in the middle of the year or something, they should have the ability. And if they pre-authorize us for numerous payments or something, then that's also a problem. And then of course the idea of holding funds in escrow, things like this. In other words, we weren't satisfied with what's out there right now, so we thought, what could we do differently? So we talked about how to make cryptocurrency work for our needs in addition to having the privacy. So first we looked at privacy preserving features in cryptocurrency like Zcash shielded transactions. We also thought about how we need networked privacy, so we looked at Tor. And we also thought about how we need to manage cryptocurrency subscriptions themselves. So the periodicity problem, the pre-authorization, where we want to make sure that the keys stay with the people, and then data standards, just general in cryptocurrency space. There's not a whole lot of data standards around how to communicate things like billing period, due date, late penalty, stuff like that might come along with subscription payments. So we had to think about how we could do some data standards for this. And of course, price volatility, we got to manage for the fluctuations right now, especially compared to fiat and during any kind of transitionary stage. So combined, this is what we came up with. These are the layers of the different tools that we incorporated. So GridSync is the application layer privacy, and this is basically just a user interface for Tahoe LAFS or Tahoe LAFS. Tahoe LAFS, that project, also open source, and this is what is used for the distributed storage. And then Zcash shielded transactions for the financial transaction privacy, and then Tor for network privacy. So here is the actual step through of how the private periodic payment protocol works. So you can see the first step is to initiate the subscription, and we do this via the Tor browser to make sure that people are coming to the web page privately so that we don't get their IP address. Of course, we have to recommend people don't go to our public site and then go to the Tor site, because then we could link that together. Second, subscription creation and invite code, and this is where, they basically, at that page, they just tell us that they want to start a subscription. And so we create a Zcash address to accept the payments and an initial database entry to just link these things on our side. And then we generate what's called a magic wormhole invite code. This is another open source project that we utilize, and it's just basically a way to send the configuration file and the initial invoice information to people. And then the third step is the client-side subscription configuration. So this happens in the client application GridSync, and this makes the connection to via the magic wormhole to receive the initial S4 configuration and the initial invoice that they need to pay. And then it updates the configurations locally and kind of interprets the structure of the invoice and can start storing things on the local machine as to about their information, their invoice and their subscription information. So this way it stays on the client side and it's not actually staying with a centralized service. And then fourth, they need to make the payment, and we need to update that they paid us on our servers. So they make the payment to the address that we told them to pay to. We watch on the Zcash blockchain to see that that payment was made, and then we confirm it and we publish the next invoice. And then the fifth step is just the reoccurrence part between this invoice and the payment. And so their client checks for the next invoice as opposed to us, kind of feeding that to them. And then, they display the updated invoice information to the actual user as opposed to us doing that in a centralized service. So that's happening client side. So this is what we spec'd out for an invoice. This is the string. And so basically this is just an example of what it looks like. In this example, it says a customer is being asked to pay 0.1 ZEC by a particular date, here September 4th, for the service least authority S4. And if the payment is made by the given deadline, the subscription will be extended by 1 month, which is some million seconds, until October 4th. So next steps for us, as we're going to complete the S4 implementation that we have of this specification. The specification itself is already published on our website. I'll put up the link next. We want to get feedback, iterate, and improve. We've got some ideas about how we can extend this further, because this was just a basic specification of how you could do this privately. So for example, there's an encrypted memo field in Zcash transactions. We could utilize those a little bit more heavily to do any kind of communication, maybe even figure out how to put invoice data in that. We could also expand on the use of Tahoe LAFS because we're having this distributed storage, basically infrastructure. We could also use elements of it to kind of communicate in a private manner to the end users about their subscription status. We also think that it could be cool to work with other wallets that are out there and kind of build in this kind of subscription management stuff into wallets. And then also create merchant payment frameworks, so it makes it even easier for merchants to handle subscription payments in a privacy-preserving way. So yeah, just in general, I hope that other people are inspired by this work, steal the ideas, not steal, open source, but be inspired by the work to do something similar, to keep privacy in mind for and doing more payment type stuff with cryptocurrencies that fit some of the more creative business models that are out there already. So here's the links that I talked about. On our blog, you can see the short post about it, along with download the specification. It's not too bad of a read, but it talks about the privacy properties of the decisions that we've made, some of the trade-offs and stuff like that we have to make in the interim. And also it's got even more detailed ideas about future work that could be done. And then also another company did a GDPR compliance assessment, basically, of this whole specification, looking at how this kind of works with GDPR. And that's also been published, and that's available online also. And so that's what that second link is. And then, of course, the contributors from my team and the Zcash team and all these people who make the wonderful open source projects that go into this stuff. So that's it. But I guess I'll leave this up.
Any questions?
Very interesting. It seems like a well thought out solution. By not storing any customer data, you comply with the GDPR really well. How do you manage the regulatory risk around?
There's one exception there.
Yeah, I'd like to hear about that. And then my question is, how do you manage the regulatory risk on the other side, where you have requirements to know your customer and concerns about the transparency of payments and being able to respond to subpoenas?
Yeah, so those are some other issues that we're going to be looking further into in the future. I have some vague ideas of some of those things, but I'll start with the GDPR part. So yeah, basically the compliance aspect of it is that we're not collecting any personal information, or at least not any that, there's little crumbs of information, because no matter how much we try to not collect any information, there could be crumbs somewhere else that then people could correlate. So we tried really hard to get as far close to anonymity as we could realistically. But yeah, so the encrypted data, so that has nothing to do actually with the payment protocol. That itself is great in terms of GDPR compliance because there's no personal data. But in terms of the fact that we're storing encrypted data, GDPR, right now I guess the stance is that encryption isn't quite enough. I don't know, there's lawyers that can talk to you in more detail about why, and there's all kinds of arguments, but the idea that eventually that crypto could be broken. But then again, we're not the only ones with that problem, so the whole world has to deal with that problem. So hopefully we'll see some good response to that in the future. But I also think that there's also new technology developments that can help that problem.
And then how do you deal with concerns about...
Oh yeah, the other ones. Yeah, I haven't talked to a lawyer about the subpoena thing yet, but I guess we would have nothing to give them. That's it. In terms of know your customer, as far as, again, not a tax lawyer, but the only thing that I've stumbled across so far is the VAT problem that we might run into, that we can't prove that, because we're a German company, so we have to do the whole VAT thing with our customers, and so we can't, because we don't know where they live, we can't prove that they don't live in Europe, so that we shouldn't have to pay VAT on them. So I guess it would just be a cost, but it's not illegal, as far as I know. But that would be the next cool thing, would be to shop this around to more really knowledgeable lawyers, if there's any here, talk to me, and just get more kind of assessment on those problems, and maybe publish some more blog posts about yeah, okay, if you have no personal data and you're doing this kind of service, then it's cool. You don't have to worry about all these compliance things.
Yeah, actually my first question was exactly about that, whether you're compliant with the MLD4 and MLD5. It's anti-money laundering directive. But my second question is, in terms of PSD2, it looks like you're a bit falling into payment initiation services. Do you look at it from that perspective, that you actually need to have a license performing such a services, and where do you stand in terms of that?
Well, I'd have to talk to, again, an expert on that aspect of it. It sounds like you even know a little bit more of the names of these things than I do. But we're not, for us, it's just another way to accept payments for our service. So at this point in time, if we were to implement this for our S4 product, we wouldn't be doing this for other people in terms of like moving money for others. We'd be just accepting payments for ourselves. So I would imagine that that would not make us any kind of like financial platform because we're just doing it for ourselves. But again, we'll see. We have it like half implemented. And also we would launch this on like a small scale. I mean, the amount of people that would pay with Zcash shielded transactions over Tor for our S4 service is probably not hundreds of thousands of people. And so, you know, I'm imagining that we can just talk to regulators and people and stuff and try to figure out like what the solution is for this. But yeah, and in terms of like money laundering and know your customer, I think that most of that applies to like financial institutions. But yeah, if you know lawyers or tax accountants, tax attorneys, things like that want to come talk to me about this, I would love to talk to them and work with people to do a deeper analysis and have better answers.
So I'm application developer, and if I would like to integrate it, are the information available on the link, or do I have to set up everything myself, or how would that work?
Yeah, so I mean, we just spec this out for ourselves. We share, like I said, the thought process, the analysis of what we did and why we did it. So right now, and then we're doing the implementation ourselves. The code will all be open source, but if you wanted to tailor it to a particular different application, then you would have to do some work yourself. It's not like a one-button solution or something.
All right, let's thank the speaker again.
Thank you.